Super excited to be here and just again, my challenge is I have 45 minutes and 9 demos, but I'm pretty sure I can handle that. It's great to actually know that Kim covered the major pillars of Synapse development. So you may treat this session as a kind of extension for 15 minutes keynote that was presented just a second ago. So my name is Pawel Potasinski. I'm a senior program manager on the Azure Synapse Analytics team. You can find me on Twitter and LinkedIn. On LinkedIn, you can also subscribe to my newsletter that is coming on a monthly basis, and I present the news from Azure Data and Power BI world there. So feel free to subscribe. Feel free to reach out to me using any channel. I will probably drop an email address later on after my presentation as well, so you will be able to contact me directly if there are any questions about Azure Synapse. Now, for the purpose of the presentation, probably I will turn off my camera in a second, but then I will probably go back with my beautiful background behind me at the end of presentation, but I will let you focus on the presentation. So the purpose of this session is to make sure that you know what showed up in Synapse in the last 6 months. So I'm traveling back 6 months till July, and I picked I selected some features that seem somewhat in some way cool for me. So it's a subjective selection. So I will try to highlight the features that, or the directions that are handled by different workloads in Synapse, but I will show you 9 specific features in demos. Now, just a quick reminder for everyone attending this session and the sessions at Data Toboggan, that in general we are talking mostly about Azure Synapse Analytics, this one. And so just a wrap up of what Azure Synapse Analytics is. It's a unified platform for analytics, which blends big data, data warehousing, and data integration into a single cloud-native service for end-to-end analytics. If you add to this services like Power BI for business intelligence and self-service BI, and Microsoft Purview for data governance, then you have the whole picture of how Microsoft handles analytics, right? Now, I will turn off my camera, as I said, to let you focus on the presentation. Okay, so here we go. Now, the first thing I want you to memorize is this, aka.ms/Synapse monthly update. Here, this is a part of our Synapse Analytics blog, where we present monthly updates. So every single month we present updates to different workloads in Synapse. If you track this address, you will stay updated, and you will make sure you know the latest announcements and features. There are more links coming in this presentation at the end, so stay tuned. Now I will cover different news or different new features in Synapse going by different workloads of Synapse, but just as a recap, Synapse is being developed in multiple different areas, because as a complex beast, as a service that covers end-to-end analytics, it has to. So we start with data integration, ingestion of data, transformation, and so forth. Then we move to data engineering. So typically we are talking here about Spark engines and developing some Python or SQL code or Scala code. Then we move to data warehousing, which is data warehousing and data lakehousing. Recently, probably even more strong stream here. Then there is a data science workload, which covers, of course, machine learning, deep learning, and everything related to predictive analytics and some advanced analytics. Then we have observational analytics, one of the most underrated workloads. Here we have Data Explorer engine, also known as Custo. Then we have business intelligence, so tight integration with Power BI. So you will see some Power BI features that actually allow you to work smoothly with Power BI and Synapse all together. And then we have data governance. Now, in this presentation, I will not cover all those pillars. I will focus on 6 of them: data integration, engineering, warehousing, data science, observational analytics, and business intelligence. And let me start with data integration. So actually, Kim mentioned what are the top pillars that we try to address using our data integration workload. So first of all, we want to make sure that customers are able to ingest and play with the data coming from actually the whole spectrum of data sources. That's why right now in Synapse and in Data Factory, which is actually very similar to what we have in Synapse, there are over 100 connectors that you can use to effectively connect to different data sources and download them to your cloud solution, to your cloud analytics solution. So that's number one. Number two, we take care about handling different skill set of people. So not everyone will be interested in developing sophisticated Python or SQL scripts or handling some super advanced and complex ETL jobs or ELT jobs. Some people are interested in UI-based solutions that allow them to easily just drag and drop some blocks and build their pipelines and transformation. So this is also an investment. Even more, we started providing some templates that address common scenarios. Also, we want to make sure that the systems playing serious role in enterprises like SAP, for example, are appropriately addressed, and that customer can bring the data from this landscape to Synapse. And last but not least, we try to make sure that, if possible, we reduce the cost of solutions for the customer. So I'm not going to click on all those links. Those will land in the presentation. You will get in PDF format. I will share the link at the end of this presentation. But I will highlight two of those features in my demos in a second. So the very first is related to how we approach the monitoring thing. So Synapse as a whole is not just about development, but also about management and monitoring. So it's important to provide consistent way to monitor your pipelines, your orchestration stuff. So this feature is not a very big feature, I would say, but I think it's quite cool, because typically in the Synapse workspace environment, you will have different number of integration runtimes being used. Integration runtime is responsible for handling your Synapse pipelines, responsible for pumping data to Azure Synapse and other things. So Gantt chart for integration runtime monitoring provides a way to visually monitor how your pipelines and activities run versus a single specific integration runtime. So whenever you deal with a problem of having to monitor only a single integration runtime, that becomes very useful. Scenarios, it's very easy to find the overlapping pipelines and activities. Also, it's easy to find to see visually the longest activities and the longest activity runs. So you can also check what's the duration deviation in statistics. So let me show you that actually. So we start by going to Monitor Hub of Synapse Studio UI, switch to Integration Runtimes, and click on your integration runtime. Then you go to Activities tab, and then you can switch from List to Gantt view. And then you see your pipeline runs. You can immediately see which activity in a specific pipeline took a longer time. You can also check what was the duration deviation for specific activity or pipeline. Then you can switch to details and see what was the set of activities executed in a pipeline run. And then of course you can dig deeper to see the specific activities, some more details, including the number of rows and the amount of data pumped in the specific activity. So that's actually consistent with how you can monitor other parts of pipelines. Previously, Gantt view was accessible for pipeline runs. Right now, you can also use it for integration runtime monitoring. Now, the second one is much bigger. SAP Change Data Capture connector. This one actually went GA recently, so you can right now use it in a fully production way. So what is this connector actually? It's a connector that uses the capabilities of change data capture in SAP systems and extracts the delta understood as changes in a data from SAP applications, the variety of them. So it may allow you to access SAP ECC, S4HANA, BW for HANA, and extract the delta to changes to data effectively, and bring only changed data to your analytical system. So that actually improves the way how you can handle incremental uploads to your lakehouse, for example. Now, this delta extractor connector uses, as I mentioned, CDC feature of SAP. So it's tightly integrated with SAP ecosystem. And it uses the operational data provisioning framework to replicate delta in SAP source datasets, which means that it doesn't use any kind of watermark. It's not that simple mechanism. It's a bit more sophisticated, as I mentioned, based on tight cooperation with SAP. So how does it work? Thanks to my colleague Ulrich Christ, principal program manager on the data integration team, who actually works directly on this connector, I can show you some demo for how this works with Synapse. So we have data flow, mapping data flow. It's actually how we address the connections to SAP CDC. So this data flow is not very sophisticated, but before you go into detail, we have to define staging areas, so just a storage that will be kind of proxy between SAP and our solution. Then it runs on the self-hosted integration runtime. It's worth mentioning. And in detail, it only consists of two blocks: source and sink. The source, of course, is the SAP system with delta data exposed. We can actually, the data contains information whether the specific records should be inserted, are new, or maybe should be updated, or maybe were deleted in the original system. Things that you have to define for the source. Here we have an inline source tag, are of course CDC connection and then linked service to the specific system. And once you have those defined, you can actually start playing with options. So options present some specific details when you connect a specific system. So here, for example, I'm using CDS, which is a kind of store where SAP for HANA replicates the data just as we have in Microsoft for D365 and Dynaverse, pretty much. And then we have the ODP name of view presenting the data, and then some additional options, like, for example, whether I want to run just the incremental changes, or should I use the full load for the as I'm starting for the first time. So you can actually start this process in any moment. So assuming that you have already loaded the initial load to Synapse, you can then proceed with just incremental refresh of data. And then there are key columns presented as a subset of JSON configuration, right? So in a sink, we define, of course, things like where the data lands. So, for example, we can land the data in a data lake in delta format. So this actually immediately brings scenarios like historical snapshot of SAP data, and then we decide which update methods we are going to support for this operation. So insert, delete, upsert, and update. So pretty much everything is here enabled. Now, how actually this thing works? So Here we had initial load already run on the system, and now we are adding a new document to the SAP system. Let's say a new order lands in SAP system. So now let's trigger this incremental load manually, and let's have the SQL statement that is run by serverless SQL to the data lake, and it checks for specific document number. And so you can see that right now this document is not here because it wasn't there for the initial load. Now the pipeline has just ended, so we can run the query again. Right here we have information that our pipeline has just finished, completed successfully. So we can rerun the script and see that the additional information, the delta coming from SAP system landed in our data lake. So that's how this CDC connector can work with SAP. Now let's switch to data engineering. So here the investment is, of course, about Spark engines brought to Synapse. So this is actually another direction that Microsoft follows as general. We try to use all the goodies that are provided by open source communities, including great Spark engine that is being developed for years right now, and it actually grew to become #1 big data platform on the planet, probably. So we have, as Kim mentioned, we had GA, generally available Spark 3.2. Also, some improvements are around bringing other languages like R to Synapse Spark. Also, there is this direction of making our Synapse Spark as much I would say smart and intelligent without any need of development from Synapse developers as possible. So if possible, we bring all the goodies related to performance to make Spark in Synapse as fast as possible. It includes, of course, the improvements coming from Apache Spark open source ecosystem as well. So things that I want to mention. Well, let's start with this one. This is a big one because it's been long awaited. So we support our language in Synapse Spark right now in public preview. So you can move your R developers, data scientists to apply their favorite language in Synapse notebooks and play with data, and prepare their predictive models and machine learning experiments the way they prefer. Look and feel of R is pretty much like for other languages in Synapse Spark. So we developed with R in notebooks. So here you can see that I'm choosing Spark R as my language. Of course, I can choose other languages still. So, and I can of course switch between different languages in a notebook if I prefer do some things in Python or SQL, for example. Here I'm loading some libraries that are already in the Synapse R runtime, so I don't have to download those libraries from external sources. Just load them into the session, and here you can see how I can switch to Spark R. %% Spark R is the magic command that allows me to switch. I'm loading here a subset of data CSV file to the data frame in R language. I can review the data, and then I can do all the data engineering with R, like for example, some column renaming, some conversion of data types, remove unwanted columns, and maybe do some calculations. So just typical data engineering like you would normally do. For machine learning and data scientists, this could be standardization of data, for example. And then I can install external packages. So I mentioned some packages are included in the runtime, but it doesn't stop you from installing external packages. So you can install packages and then load them to the session. For example, to use some more sophisticated ways to visualize your data and analyze them in your way. So it works pretty much like for Python developers. With PySpark, you can do pretty much similar things, right? So here I'm using some visualization libraries to produce quite a sophisticated view on prices of avocado in different parts of United States. And here is the violin chart presented as a part of your notebook. Notebooks are, of course, a great way to not just experiment with data and write code, but also document things. And here you can also plot some, other charts, like maybe run some time series analysis. So what was the changes and trends of prices of avocado in specific region of United States. So as I mentioned, here is the limit. The limit is actually in your head, and then the libraries that you can use with R. Now, I will not stop with Spark 3.2. This is, of course, generally available. So just to mention, this confirms the direction. We want to make Spark as fast as possible and out of the box. So changes and improvements in Spark 3.2 were related mostly with performance, like improvements to small query execution, adaptive query execution. So just out of the box, Spark becomes faster and faster with every release. Also, popular libraries like pandas are moved towards distributed libraries. So distributed versions of old school libraries are brought to Spark. But as Kim mentioned, this is not the newest stuff, because we've already announced Spark 3.3. Actually, I noticed recently that we took off the preview flag from Spark 3.3, so it's likely that we will announce general availability quite soon. So the major thing here from the direction that we are heading is probably updating Delta Lake from version 1.2 to version 2.1. Some significant improvements actually showed up in versions 2.0 and 2.1. So this is a big one. Of course, again, performance improvements out of the box coming to Spark, as well as support for different mechanisms like Bloom filter joins are here. And again, improvements to libraries that are commonly used by developers like pandas also are here. So for Spark 3.3, I picked two features that I will demo for you. Now, the first one will be optimized with Z-order. This is for Delta Lake storage. So here I'm using a notebook that will run on Spark cluster using Apache Spark version 3.3. So that's the prerequisite you have to prepare before you start playing with Spark 3.3. Now this notebook is quite simple. It loads some sample data to a data frame. So I'm taking sample open data set, New York City taxis, I'm loading 3 years of data into a data frame. Then I create two tables. One will be called trip, and the other will be called trip optimize the order. Both tables land in a similar location, my sandbox layer of data lake, but please notice that both are delta tables, so which means that they are using delta format. Now I'm on top of the second table, I'm using optimize with the order on TPEP pickup date column. What does it mean? Let me show you that by examples. So let's first see how the files under both tables look like. So here on the left side, I have my files under trip table, and you can notice that the size of the files is like 160, 150 megabytes. On the right side, you have the optimized table, and you can immediately notice that the files are bigger. So the optimize command actually coalesces files into larger files. So the listing of files for serverless SQL takes much less time, especially if you have a number of smaller files. Now, this is not the only change to the table that we did with this optimize with the order The second change will be much more visible when I switch to serverless SQL queries. So I executed two queries, one with my base table trip. So here I'm looking for a specific date. I'm aggregating, I'm calculating average tip amount for the number of passengers. I'm checking whether there is a dependency between passenger count and the tip amount. So here I have my result set, but the most important stuff is in the messages. This particular query scanned 378 megabytes. So if you realize that you pay for the amount of data processed, that's an important information. And it took 3 seconds to run. Now, when I switch to the query run on top of optimized table, pretty much the same query, the same result set, pretty much everything the same. I noticed that the time didn't change much. I mean, it's 3 seconds. But the size of data that was scanned by the query is 10 times smaller. So that's a significant improvement to how much you will pay for your serverless SQL when the number of queries in your workload will be quite significant. So you can see that there is actually an immediate gain. Also, you will notice improvement in performance. This data set was not that big, so probably that was the reason that why both execution times were pretty much the same. Okay, now let me switch to the second demo. The second demo is related to time travel feature of delta tables. So here I'm having my delta table called demo Spark 33 trips. So the data looks like this. I'm connected again to Spark 3.3 cluster and execute just a simple select 10 sample rows from my table. Notice that for the first record with trip ID 1, I have passenger count equal 1. That's an important for the future of this demo. Now I can describe the detail of my table just to make sure that it is delta format indeed. So it is delta format. It is stored somewhere in my data lake as well. So if it's delta, then I can proceed with DML commands like, for example, update. So here I'm updating trip ID 1 and setting passenger count to 3. Notice that the execution of this query presents a data frame that says how many rows were affected by the operation. Now, if I select from the table, the passenger count, of course, changed because I did an update. But then I can play with my time travel feature in delta tables. First, I can describe history. This shows me how many versions I have for my table. So describe history, and I have two versions. One coming from the update statement. So version number 1 is coming from update statement. So how can I play with this time travel? Right now in Spark 3.3, you can use timestamp as of and refer to specific moment in time to see the version of your data. Yep. I will take questions at the very end. Thanks, Andrzej, for dropping question. Because of the nature of my recorded demos, I will take questions later on. So you can see that referring to specific version shows the historical version of data. And also you can go to the specific version using version as of. So the difference is that in previous release of Delta that was present in Spark 2.4 and 3.2, we could actually access this history of data only using other APIs than SQL. Right now, you can, if you're a SQL developer, I think you will value this update a lot. Let me switch to the data warehousing. So here I will highlight two features related to serverless SQL. But also I will point some features that will be interesting from perspective of classical data warehousing, so dedicated SQL pools. So let me start with this. You can create SQL objects and users in lake databases created with Spark and the notebooks right now. So what you can do, you can create views, stored procedures, and inline table functions. Those objects will require custom schema created in Lake databases, and then you can also create Lake database scoped users. So without creating any login, you can add user to your Lake database and then play with adding those users to, for example, specific rows in a database. So how does it work? Here I have my Lake DB with 5 tables. Those are Delta tables, by the way. And I'm connected to this database using serverless SQL. So changing the context to this Lakehouse database, this Lake database, and I try to create a view. The first attempt will fail because I'm trying to create this view in the DBO schema. So as I said, DBO is reserved for the tables and not for SQL objects that you can create as your custom ones. So I'm creating a schema called SQL. And then I can use my create view statement to create a new view in this specific newly created schema. And I can see that my view actually works. So I can go through this view and see the data coming from my Delta tables. Also, I can create stored procedure with default parameter value, for example. So here I had just a simple aggregation run on top of my Delta tables just to show you that it's doable. And then I can execute my stored procedure just like in typical SQL engine and see the results. Now, the challenge here may be that you are not allowed to grant permissions on top of those objects. So the use case for those objects will be rather, handling the data, building some transformation processes on top of Lake databases. This can be quite useful, for example, for data coming from Synapse Link for Dataverse to Lake DBs. So again, be aware and read the documentation before you start implementing those objects at scale. The second one feature I want to highlight is Spark Delta Lake tables being available and able to read by serverless SQL pool. So if you create Delta Lake tables in Spark and have them in your Lake databases, you can use serverless SQL to access them immediately. How does it look like? A little bit behind the scenes. So actually, we got external tables created in Lake database. And that's how serverless SQL accesses this data. So if we script one of those tables, I can immediately see that, yes, it is Delta table, but as you can see, it's being created as external table with a data source defined, and it uses Delta format. And of course, having this kind of table immediately allows me to use serverless SQL to query this data, so I can just simply run select statement on top of this Delta table. So why this feature is cool? Because you can immediately use serverless SQL to access the data prepared by your Spark engines and written to Delta tables in Spark systems. This is a part of metadata sharing between Spark and serverless SQL. Now let's move to dedicated SQL pool. I will not present demos of that, but just to mention, we have merge SQL statement generally available. So this allows you to actually perform in a single SQL statement, insert, update, and delete operations. We have multi-column distribution in public preview. This allows you to align capabilities of dedicated SQL pool to existing data warehousing systems like Netezza or Teradata. So you can actually think about migration between those two because typically you will have multi-column distribution in those systems. So with multi-column distribution, you can choose more than one column to distribute your data evenly across different nodes of distributed data warehouse. And that, of course, improves the performance because the performance of your queries will be always as good as the slowest or the biggest distribution of your data. Now, we also have a public preview of Distribution Advisor, which is a set of objects, SQL objects that allow you to get advices on how you should distribute your data based on the queries collected by the dynamic management views in your database or by queries provided by users. So you can actually provide your own queries. So here is an example. We have a table which is distributed with hashing mechanism on top of date of sale column, and the advice after we run this set of experiments for Distribution Advisor and provide specific queries used for the table. The recommendation is that we should actually change the distribution and switch to product for our hashing mechanism, and that will improve specific queries used for checking things with Distribution Advisor. Distribution Advisor is a part of Synapse Toolbox available under aka.ms Synapse Toolbox. So there are more useful tools for you prepared mostly by our Synapse CSE team, people working hard with the biggest customers using Synapse. Let me switch to the data science one. So with data science, key pillars are, of course, to tightly integrate our external services like cognitive services, Azure Machine Learning with Synapse, but also to include and allow easy use of well-known open source and external frameworks or language models or models like OpenAI. OpenAI recently, I think we all know that it's something behind GPT chat, so pretty much familiar one, a famous one. So this one is also being a part of investments of the data science team behind Synapse, and also full support for MLflow. So make your data ops processes in place, built easily and based on top of trusted mechanisms. That's something that we try to build. I think also very cool is this no cluster requirement for running experiments using Binder. This is another feature coming with Synapse ML 0.10. So with this version of Synapse ML, the open source Spark library that helps data scientists to simplify and make their work more productive, it actually comes with several improvements. First of all, integration with OpenAI, then full support for .NET, C# and F#. Then you can use Binder without any use of clusters to experiment and run your live demos in browser, and then you can use MLflow support to build your DevOps, so your MLOps experience with Synapse ML. So for this demo, I will credit my colleague Mark Hamilton from Synapse data science team. Mark is sitting behind Synapse ML. So give some thumbs to Mark. So the demo you will see actually is Mark's demo. So I will just try to elaborate on this demo as much as I can. So we'll start with uploading some unstructured documents to storage, like receipts. Then we'll apply form recognition. This is actually something that is well known from Synapse ML. Then we will learn from ontologies to make sure we flatten JSON responses from form recognition to some meaningful tables. And then we will apply distributed translation to make sure that our document attributes are translated. And then we create custom search engine with some fancy emojis using OpenAI. So let's start by uploading the data from the data lake. So here is nothing sophisticated, just loading the data to the data frame. I'm having a couple of PDF documents looking like this, pretty much like a typical invoice where you have, seller, buyer, and the line items, right? Now, Next step, we applied the form recognition. So form recognition, just a single line of code applied to the data frame, and we have the results in a JSON format. So pretty much readable, but still far from ideal. We want to have separate attributes extracted from this set. So we use ontologies. Again, a single line of code. I'm not going into details of PySpark code because it's not the purpose of this session, but just every single thing, every step we are taking is being done with a single line of code, and we have a table. So once we have a table, we can use translations. Again, a single line of code on top of the selected attributes to translate them into several languages at a time. So here I'm deciding to translate to French, Russian, and some other languages. So you can see that it's actually an immediate effect of an execution of a single line. And then I can also play with some more fancy stuff. Like, for example, let's provide some templates how to translate words into emojis to create some more, I would say, picture descriptive attributes in our dataset. So let's create emojis from text based on what the model learns from our inputs. So I'm saying that 2 ducks should be translated into, well, 2 ducks as emojis. Light bulb should be light bulb. 3 pictures should be 3 pictures painted with emojis. So here I have this algorithm used. Again, just a single line of code. I provided prompts, the model, and then the model is used. So you can see it provides some emojis, making this original description a bit enriched. I know it's maybe not the business case, but I think it's quite cool. So you can now switch to visualization in Spark Notebook and see that the emojis are also appropriately applied. So imagine what you can do with OpenAI based on that, and then you can also create, search index over the forms to create some applications and actually make sure that you make it available to API. So that's actually how Synapse ML works. It simplifies the way data scientists work from data, ending up with some external data sharing and presenting people with meaningful APIs and models for use with external tools. I think it's pretty cool. And as you probably know, we invest more and more in OpenAI. So ChatGPT should also come up sooner or later to analytical ecosystem of Microsoft. Stay tuned for more. Now with observational analytics, I know I'm running out of time, so I'd have to speed up. So here I picked 2 demos because I think that somehow in SQL language sometimes we miss what KQL, the language for log and telemetry analysis, presented in a Custo offer. So let me present you with 2 operators in my demo. So one will be parse key value, parse KV. This actually takes from my trace log tables, which contain properties column. As you can see, this properties column is actually a JSON data. So I can show you just this single column and see that it actually contains key value data. So if I want to extract this, parse KV works as a charm because I can simply specify the number of attributes, the number of keys, and it will extract for me keys as columns and values as values of those columns. So execution of this query will result in 3 new columns, size, format, and row count coming from key values. Now this is much more sophisticated because scan operator will allow you to do some process mining stuff, or let's say prepare sequences of steps. So here I will do some example based on Microsoft stock. So here I'm creating a process. I'm taking a starting date and I'm trying to find how many days in a row the price of Microsoft stock was increasing. And if I find the condition where the new day brings lower price, then I'm closing the series. So here I have in my result data set of this subquery, I have my MID column showing the series, the number of series. So I can identify this single series of increasing price using this column. And then the easiest part is just to summarize the data using this MID column to find the longest period where Microsoft stock price was growing, was increasing. And I'm selecting the top one, the top ones ordered by days. So here I can see that between 2019 and today, 10 days was the longest period the prices were growing. I have 1 minute left. So just a quick recap of what's new in Power BI from Synapse perspective. I selected two features, horizontal fusion, so reducing the number of SQL queries being sent in direct query by visuals, so DAX code executed behind the visuals. And the improvement can be quite significant. Here you can see an example of improvement from 23 to 4 seconds in total. So imagine you can flatten 6 queries to just one SQL query going to your SQL endpoint of Synapse Analytics. The other one is optimized ribbon. I have a demo on that, but I don't have much time. So just a recap of this optimized ribbon. It's in preview in Power BI Desktop right now, so you have to enable this feature. But what it does, let me just maybe switch to the further part. So first of all, it allows you to reduce the number of interactions in reports. So it may actually cause that clicking on any slicer requires applying the slicer to run other queries in the report. This is what you can do. You can also customize the way how the visuals will play with each other, how filters and slicers will work against other visuals. But also, you can go and pause visuals. This is pretty cool because if you have a direct query report, you can stop queries being sent to the source, for example, to Synapse, and then you can play with single visuals using Performance Analyzer. So you can grab queries that occurs behind a single visual by attaching this single visual to my Performance Analyzer. So now I'm only analyzing a single visual. So you can check how many queries were sent to from the specific visual.
So yeah, I think we're.
I know.
We'll wrap up now, Pawel. If that's okay? Brilliant, brilliant session.
Wrap up. Call to action for you. Go to aka.ms Synapse Community Resources. I've already pasted this link in the chat window, but if you don't have it, grab my presentation. It's on GitHub/PawelPO/presentations. There my presentations are available in PDF format, so you can grab this presentation, have access to all the links. Thank you. I will take the questions in the chat window probably. Thanks.